we're going to learn a little bit about working with fractions in our linear equations. So in a situation like this, where we've got to simplify 12 times x over 3, I'd recommend starting off by putting the 12 into, or turning the 12 into 12 over 1, turn that into a fraction, because we know how to multiply fractions together. Next, we can do some cancelling down, because 3 is going to 3 once, and 3 is going to 12 4 times. Well, that was quite easy. 4 times x over 1 times 1. So the answer is 4x. And there's no point in putting it over 1. We don't really need this bit. So there's our answer. Now we're going to try and simplify an expression like this. 2x over 3 divided by 8. Well, top tip number 1, turn the 8 into a fraction. Top tip number 2, dividing fractions is easy as pie. Flip the second and multiply. And we end up with something like this. Now, on the top we've got 2 times x times 1, and on the bottom we've got 3 times 8. So we can do a bit of cancelling again. 2 is going to 2 once, 2 is going to 8 4 times, which leaves us with just x on the top and 3 times 4 on the bottom. So our answer is going to be x over 12. That's the simplified version of our original expression. We can up the ante a little bit and put a little bit more on the top and a little bit more on the bottom, and in this case we can see that the 5 here will cancel with the 10 here, because 5 is going to 5 once and 5 is going to 10 twice. There's no more cancelling that can be done. 3's don't go into 13. So we've got 3 times 2 times x on the top, and we've got 1 times 13 on the bottom. So 3 times 2 is 6, x times x is x squared, that leaves us 6x squared on the top, and 1 times 13 is 13 on the bottom, so that is our simplified fraction. Let's up the ante just one more time. We've got a slightly more complicated expression which involves dividing fractions. So dividing fractions is easy as pie, flip the second and multiply. And when we've done that, we find that we've got some nice cancelling that can be done. 3's go into 3 once, 3's go into 9 3 times. X's go into x once, x's go into x once. 5's go into 5 once, and 5's go into 20 4 times. So we've left ourselves with 1 times 1 times 1 on the top, and 3 times 4 times 1, which is 12 on the bottom. So there's our simplified expression. Well, all of that simplifying expressions was all well and good, but mathematicians love to solve equations. We love to find x. So here's an equation, 3x over 4 is equal to 12. So I'd recommend the first step is to change that into a fraction as well, 12 over 1. That's going to make some of the next things we do a little bit easier. Now we'd like to get rid of fractions altogether, so we've got to try to lose this denominator of 4 down here. Well, this really means 3x divided by 4, so the opposite of dividing by 4 is multiplying by 4. In fact, I'm going to call it 4 over 1, just again to keep the fractions nice and easy. But now I've unbalanced my equation. The left hand side isn't equal to the right hand side, so to balance it up again I've got to do the same to the right hand side. And now I've got that, I can see that 4's going to 4 once and 4's going to 4 once. So I've got 1 as my denominator on the left hand side, and I've also got 1 as my denominator on the right hand side. So if I multiply that together, I've got 1 times 3 times x, that's 3x on the left hand side, over 1, so that's just 3x, and on the right hand side I've got 12 times 4, which is 48 on the right hand side, over 1, so that's just 48. Problem is, I don't want to know what 3x is, I want to know what 1x is. So this really means 3 times x, or x times 3, so the opposite of timesing by 3 is dividing by 3. So now my 3's will cancel out, 3's going to 3 once, remember, but I've unbalanced my equation. So because I divided the left hand side by 3, I've also got to divide the right hand side by 3. And now on the left hand side I'm just left with x, and on the right hand side 48 divided by 3 is 16. So there's my answer, x equals 16. So finally in this video, let's look at this equation here. I've got fractions on either side, and I'll let you into a little secret here. The answer is not going to be particularly simple. X is not going to be a whole number. So let's have a look at what to do first. Well, obviously we want to try and get rid of our fractions, so I'm going to multiply both sides by 5. I'm aiming to get x on its own. So first of all, let's try to eliminate the denominator from the left-hand side. So in order to do that, I'm going to multiply both sides by 5 over 1, because that means that on the left-hand side, 5 is going to 5 once, 5 is going into 5 once. So I've got rid of my fractions from the left-hand side. And 1 times 2 times x is 2x, and 1 times 5 is 5, and 3 times 1 is 3. So 2x is equal to 5 over 3. Now I want to know what 1x is equal to, so I've got to divide both sides by 2. So I'm going to divide the left hand side by 2 like that, and I'm going to divide the right hand side by 2 like that. And on the left hand side, the 2's are going to cancel out like that. So this means that on the left hand side I've just got x, and on the right hand side 5 over 3 divided by 2. Well, that's a little bit confusing, but if I turn the 2 into a fraction by making it 2 over 1, remember, dividing fractions is as easy as pie, flip the second and multiply. Which makes the calculation look something like that. 5 times 1 on the top, 3 times 2 on the bottom, and our answer is 5/6. And as you can see, it's not a whole number, but it is a correct number.